Hey, welcome to another coding session. So from what I've shown in the last session, I have this massive list of stuff to get through. And this is kind of the list where I feel like once I've got through all this stuff, I feel like the language is in a great place. Maybe there'll be some more features after this, but I feel like this is the core of what I want the language to have. And the bugs that need to be fixed that I know of at the moment, all that kind of stuff. And then I have this big list of cleanup items. I've kind of separated out some things that I think are like just easy little things. So they're easy to find because that's the kind of thing I'd like to do after I do something bigger and if I have a bit more time in the session. It is part of cleanup, but these two here are kind of what I want to have a go at right now. The reason is especially this one is going to be quite helpful in allowing other features to be implemented. So this one says store identifiers for different levels separately. What I mean by different levels is kind of the levels that are in our program is we have, maybe, I never do this anymore. I should really get back into the habit of using this whiteboard some more. We have this AST tree. It's kind of like that. Let's make a new spot. So we have the AST, but then kind of in parallel, we also have this other setup. It's over in this program file. Program. See, we have a program and we have modules, we have procedures. So those are kind of the levels that I was talking about. We have a program which can have multiple modules, like module A, module B. It's been a while since I've used this program, but I think it's just A to make an arrow. And then within module A, we have like proc A, proc A, and we also have like proc main, which is like the main body of the module. If we go to our example code, so every file is a module. So all this code here, like all this code down here, there's all these things I'm calling procedures, and I have for loops and all this stuff, and it's just in the main body of the file. It's not within a procedure. Like this is a procedure. So this is the body of a procedure. But a lot of this code is just in the main body of the file, and that's what I mean by the main proc of the module. And when we go to generate our assembly, what happens is that if I say like proc A main and proc A, it's almost like A dot main, because they're like namespace, so it could be like A dot, I don't know, init or something. Could be another procedure. And then over here we could have B dot main and B dot show. I don't know, some procedure name. Like that. So these are kind of all the layers. And then within any procedure, you can have like scopes. And within a scope, you can even have like another scope. You could have nested scopes. So these are all different sort of like, yeah, they're different scopes. You could think of it as different thing. Like this program is like everything But within the program, there's different modules. Within the modules, there's procedures. And within procedures, there are scopes, which are also going to have nested scopes. One of the things that I want to add is you should be able to have like proc b.show.foo. You know, you should be able to have even a nested procedure. This is not implemented yet. I'll leave it there because it's like the intention is that it will be implemented. So why did I get into this? Because right now when we're doing our type checking, we have this context object that we feed in right at the start, and it maintains a list of identifiers that we have. And then whenever we go down a level in this tree, we basically take a copy of that context and pass it down. We take it, and then we might go through the module for a while. And then when we get to this procedure, we take a copy of the context and pass it down. And that's how, you know, because we take a copy and pass it down, then we might add more identifiers that are in this procedure. But then we might, when this procedure finishes and we go back up here, then we resume with the old copy of the context, which did not have the identifiers from this procedure. And that's how we make sure that at any given point, the identifiers that we have access to are from either the place where we are or anything above it. That's the idea. And we have the concept of, when we do a copy, we have the concept of whether it's inline or not. So when we go to a procedure, then we go to a scope, we call that an inline copy of the context, because when we go this level down, we want to take everything that was available here. You know, any variables or whatever, they should be visible within here. But when we go from the module to the procedure, this is not an inline copy. So the impact of that is that the only things here that can be seen, the only things declared up here that can be seen here are like procedures and static variables. I mean, we can go to the code for it actually. Type checking context. This is where we do it. So it's either inline, like I was saying, or types, modules, and these three allocators, GSL none and static. So anything allocated in that way, which is, I kind of consider to be static things as a whole, and then modules and types. Those are the only things that will get copied from here down to here. Because if there's a variable declared in here, it should not be visible here, you know, like a stack variable. Okay, so what's the change I want to do? The change I want to do is that I want each of these levels to, well, maybe not including scope, but each of these levels should have its own list of identifiers. So this one should have a list of all the sort of, I guess you could say, global identifiers. This one should have a list of all the identifiers declared at this level. This one should have all the identifiers declared at this level. So then when we're in here and doing our type checking, we want to say like, hey, I've come across this identifier. Is it a valid identifier? What is it? First I'd check this list, then I'd go up here and check this list, then I'd go up here and check this list, you know? And if I'd never come across what I'm looking for, then it's an undeclared identifier. And yeah, that's basically it. So yeah, that's the change I want to make. And that's going to give us some flexibility to do some other features, like nested procedures, like this here is helped by this new structure. It also allows us to change the architecture of our compiler, which I would like to do, so that basically all these procs could be done in a multi-threaded fashion. You can do this procedure on one thread, and this one on another one, and this one on another one, this one on another one. You can do them whenever you like. And we know that the things above it, we know the identifiers for those. Yeah, so there's a few things that it's going to make quite helpful for. So let's have a go at it. So where do we want to start? Well, the first thing is, I guess we go to this program. And we can see that I'm not going to add it to procedures yet, the procedure level. So, but we are going to have it, so we have identifiers at the module level, and I'm going to add them to the program level. We might not need the static files anymore because identifiers should cover that, Yes, we have at the program level, the module level, and then there's also the context itself. So the context is still going to have identifiers in it. So that will be used, because our inline copies still need to happen. Like if we're in this procedure, then we go into the scope. And then once we finish the scope and go back, we just want to discard anything that got added here. Okay. All right, so we have this. New identifiers here. I'm going to let's put it in the context. I think that's a good enough place for it right now. Get identifier node, because it's a bit more involved now to find an identifier. So it'll be pointed to an AST node that we get back. And I guess we pass in a context and the identifier we're looking for. So first we do what we would normally do. So if identifier in context.identifiers, let's return a pointer to what's in that map. Easy. Just to keep this happy, we'll return nil by default, so that means we didn't find it. So the next thing is we get the module, a pointer to the module, so that's context.program.modules, come on, light. Maybe I should Google that or something. Seems a bit shitty that I get a nice light and it's like, doesn't want to work. Well, the whole job of a light is just stay on. I feel like that's its only job. Anyway, getting sidetracked because of my stupid light. So first we look in the identifiers, then we look at the module level, and then we look at the program level. Right? So context.program. And if none of those levels have it, then we return null. Simple. Okay. The other place that's just come to mind is module, which is, and I always thought this was a bit, well, for quite a while I've thought this is a bit weird. This is where we declare all these things. These are like the global things, all of our built-in types and a few built-in procedures. And it felt a bit weird to me always that we're like setting this up per module when it's like a global thing. So we go back to program here, and I'm just going to make a init procedure and put that there. Pass in the program because that's what we're initializing. There we go. And so we set up the program identifiers. I feel like that's everything we need to do there. We're going to need to change this. But then we can go to our main. And the first thing we want to do is init the program. So set up all the global identifiers. Cool. So that's that. I don't think we're going to do anything. Well, we probably are. So this whole thing here, this is where we're copying the context down. Now I said, because we're not really doing this anymore, we're having a separate list in here. This only really makes sense for scopes now, when we're going into scopes. So it's always inline, which means this always resolves to true. So this gets reduced to this, always inline. So that can just be like that. We don't need this inline flag. So that simplifies that. Let's find our usages of it. So for the for loop, we do it for the for loop because we have, I'm not sure if I changed these to statements. I'm not sure if I like that. But we do it like this because when it comes to a for loop, where is a for loop? Like this declaration here should be scoped to the for loop. So that's why we create this copy of the context just for use within the for loop, so that when we finish the for loop and go back out and use this original context anymore, it's not containing, what am I looking for? Yeah, it's not containing this anymore. So we could, declare X down here and it's not going to conflict. So for a for loop, we do need this copy. We'll get back to procedure. Scope, like I said, scope, we also need to do it for the same reason. But procedure, for each procedure, we can basically just create a whole new one. Because we don't need to copy this stuff. We just want this. So why don't we just create a new context? We can just go like this. So it takes the procedure name, this procedure name, like that. There we go. So yeah, I think that's kind of the context sorted. The one last thing is like this. Normally, when we're looking for an identifier, all we had to do was look in this map. So I want to check everywhere that we reference this and make sure, because a lot of the time we're going to need to call this procedure instead, so that we look in multiple places. So let's have a look through these. This is adding to the identifiers. I think that can just stay as it is. So at any given point, when we're doing a statement or wherever, if we want to add an identifier, that's fine. It's when we come back. So when we're finished doing a module, then we assign it to the module identifiers. Because once we've finished going through all of the, once we've got to the end of the body of the module, what's left in identifiers should be only top level stuff, There shouldn't be anything that was in nested scopes or anything. So this is module identifiers. So we have that maintained. Program only ever contains those globals, and then the context contains the current stuff. So that's all good. Yeah, so that's fine. So here we're checking whether we're saying it should not be in identifiers. So if we say get identifier node for this, need to have context. So if it's not in there, we're saying that should be nil. Okay, so let's move to the next one. Again, we're adding to the identifiers. I think that's fine. Oh, this is our copy. So this is also our copy. And then there's two more that are the same. So we go to here. Here, when we're referencing things like this is a built-in type. I'm just going to take a shortcut and say .program because I know that's where it is. Yeah, I think that should be fine when we're like explicitly looking for built-in types. We can just do that. I think there's quite a few of those. Okay, so here we're looking for in the identifiers, and this is like the last thing we do. So I think we can just go like this and say identifier node is get identifier node with the context and the node.value. And if that's not nil, then we go in here. We already have it, like so. And if it is nil, and we're not allowed undefined, then we give an error. So that's that one sorted. Again, this is like a built-in type. There's another one. This is checking that it's in. So get identifier node context node.value does not equal nil. Like so, this is adding to identifier, so that's fine. So is that. This is assigning once we're done. Here's another built-in one, a couple of them. Looks like there's quite a few actually. Those are all built-ins. So is that string, it's a built-in type. Okay, looks like this is the last one. So this is kind of like what we did before. Identifier node is get identifier node context node.value. And if it's not nil, we go in here. I think we can probably just go and if it's not nil and it's a type, then we do the thing. Okay. Cool. Let's close a lot of these files. And I just want to do another search on identifiers to see that everything makes sense where we're still. Yep, so these are adding to it. This is part of the copy. And that's when we're searching for it, assigning to it. Yeah, and copying over. So I think that's all good. Is that it? I mean, it's working slowly. I'm not sure why that was so slow, but deciding to go slow today. Okay. But it worked. Huh. That's one of those situations where like you make some code changes and I was not even sure if I had done everything I needed to do. I was like kind of, maybe there's something more. I can't remember. Let's just try running it. And then it just worked. Kind of surprising. Okay. Now we're in the module file, which is actually where I wanted to be because we've taken care of this. And this is something I would like to add. Allowing links, imports, and type aliases in all scopes. So currently, we have imports at the top level. We have, if we go to like OpenGL, we have a link at the top level. And what was the other thing I mentioned here? Type aliases. Type aliases also we just have at the top level. I don't know where an example of that is. Boomstick probably has one. Yeah, there's a type alias. I would like to do that, within procedures, within full, anywhere really. I would like to do those things. And especially when we get into more of our performance improvements, it could be great. Like if we look at memory, so that's only used in Bang here. I mean, if you're importing Boomstick, there's a very high chance you're going to use Bang. But maybe you import Boomstick and then you stop using Bang and then you forget to not import Boomstick. You could put this down here, right? And once I've got more into the performance improvements of the compiler, this procedure should only get type checked if it's used. Right now it only gets generated if it's used, but there's no point in type checking something either if it's not used. And if it never gets type checked, this import never gets evaluated, and we never have to worry about this file either, unless maybe that file gets imported from somewhere else. But it's kind of like, it's like scoping the imports. So maybe we don't need to import so much stuff and we can compile faster. Linking something, maybe that's a thing, like being able to do that there. I mean, it's not so important, but why not? And the other one was like my I64 equals I64. And we can put that there. So these are kind of all the things I would like to do. So I guess this is our test case. Right now, the reason that we can only do them at the top level is because it's when we type check the module that we have all this stuff. If it's a link statement, do the link stuff. If it's an import statement, do that stuff. And if it's a type alias, do that stuff. Also, the other one is procedure. So one of the steps to doing nested procedures is to move this also. So we'll move that as well. And it will mean that we can do strengths nested proc. So we should be able to do that also. But there needs to be, well, the main other thing that needs to happen with procedures, and also, well, with anything that's has a label in the assembly in the end, actually, is that we need to namespace this a bit more, right? In the assembly, it should be like boomstick.bang.myproc. But at the moment, it's just going to be boomstick.myproc, which means that it would conflict with this guy. If we did that, then this myproc would conflict with that myproc, which it shouldn't. That should be valid. But we're not going to tackle that right now, the naming thing. We're just going to make it so that it's possible to do this here. Okay. I don't know if I import strings here. Looks like I do not. We could put it here, right? Okay. So let's move this stuff. Type alias procedures. Oh, interesting. Oh no, these are the regular statements. I just saw that and I was thinking it's the type alias thing, but this is the regular statements doing regular type checking. So it's all this stuff up here you want to move. So what I'm going to do, it's a bit of a weird grammar change, but I want to make a statements. So this will be statements and this will be statements. I think that's the only place. Yeah, 1 of 1. So multiple statements can either appear in the program. Well, I guess that's more like a module. Has multiple statements. And a scope can have multiple statements. That's it. And the motivation for that is that then, like, we copy this module and we say statements, type check statements. Yeah. So I'm not even sure if we're going to need slice in this one. What grammar we're done with, but so module, we don't even need this link, import, types, procedures, all that stuff we don't need. Well, I guess even this is like part of it, right? And this, where we type check the statements, the procedures. So I think it's like basically just type checking the statements, which is how do I get the nodes that I want? I guess it's these, right? So it's kind of like, this is the main procedure. So the statements, so let's make it a slice, I guess. So this guy wants statements, which is a slice of AST nodes. So he's just looking through these statements. One other thing I had been thinking about was that, you know, these are all separate loops, but I think they can all be done at the same time. I don't see why not. So we can say, if it's a link statement, do the link stuff. Otherwise, if it's an import statement, do the import stuff, which is quite a lot, it looks like. Resolve types, I guess, always happens. Let's just chuck that at the top. So if it's a type alias, we do the type stuff. Somehow I feel like type alias should be like at the top, and these can be else ifs. I feel like typing stuff is more important than like this link and alias thing, link and import things. Maybe procedures is also more important than those other things. But anyway, we'll leave this one down here. So this is the procedures. If it's a procedure, we do this stuff. So this is our first pass. Our first pass is that we take care of types, links, imports, and creating static procedures, which means we need the static procedure names. Wherever I had that, procedure names. So let's put that up the top, because we're going to add to that list. Now we take care of the main procedure. Well, it's not the main procedure now, it's just, yeah, it's just the statements. So of this list of statements, now this is kind of like the main pass. This is where we do the standard type checking stuff. These were all kind of like special cases that we took care of. Then we do the main type checking stuff, which excludes type aliases and procedures. Once we've finished with that, we have our identifiers, so we can do that. And then any procedures that we found, we kind of recurse and take care of them. Yeah, I think that's pretty much it. So that's the statements, and the module just does that. Oh, it also does this. So I don't think that, did I do that still in here? Because yeah, I feel like that's not a thing. That should not be a thing that we do in here. That's really module specific stuff. We don't want to do that at every scope. That would be a problem. So the one other place was scope. So here we want to do this, and I guess it's like node.children that we're going through. Like that. So now every scope is going to do all that work. It's basically all these special cases is what's being added. You know? So now we're doing everything at every level. I think so. Let's see what happens when we run that. That has caused some issues. Okay. Linux 4.3 syscall is not defined. So here it's saying that it can't find syscall. So we've gone into a procedure. So from this module, we have our context. We're doing our statements. It might be because we're doing all the procedures, type checking all the procedures. So we're going into Linux. We're going into this procedure and type checking this, but this has not been added because we're still in here. We haven't come back to here yet. So the identifiers have not been added to the module, but we're going in and we're like, hey, let's type check this procedure. And that ain't working. That's like the wrong order. And that kind of leads me to something else that I wanted to try, actually. And we have a bit of time. It's also something that will be helpful for the performance stuff. And essentially what it is that when we come through here, you know, we're saving this list of procedure names. I guess the simplest, no, instead of having this here, we're going to put it in the context, basically. No, not the context, because the context, we have all this copying business. I think the easiest place to put it would be the program. So in here at the program level, we can put, I'll put it down here. It's like the queue. And it's like a dynamic list of strings. I think let's leave it at strings now. So those would be, basically it'll be a queue of procedure names that we want to process. So instead of this, we're going to say context.program.queue, add it to the queue, and it needs to be the qualified name. Right, so we add the procedure to the program and then we say put it on the queue, it needs to be processed. And down here, we don't do this right now. So we don't process any nested procedures right now, any nested procedures within their statements. Instead, we do all the processing, and I guess we need to have like a loop. So like at the main level, maybe we're type checking the program, which is basically just type checking the main module. So then maybe after that, we can say, while the program dot queue, while the length of that, while that's not empty, basically, while the queue is not empty, we want to, oh, did we cut that stuff out? This stuff. We want to do that stuff. Program, here we go. I thought that I went down to 2 spaces. Maybe I didn't. This is Odin code even. Huh. I was sure that I went to 2 spaces, so let's do that. That's better. Okay, so we want to do this now. So while there is stuff in the queue, I want to process the queue, but while we're processing the queue and type checking all these statements, what might happen is things will get added to the queue. Is that a problem? And what happens when we get duplicates in the queue? That's the other question. What happens when we get duplicates in the queue? If we've already done something, then there's no need to do it again. Okay, I think I'm just gonna like do just like a really simple solution to this. Might not be the best, but if we have here for our procedure, if we have, yeah, I definitely want to do this differently later, but if we say we have a type checked bool, so we know if it's been type checked. Then when we go back to here, I think we can get rid of all this stuff. When we go back to here, we can say, well, there's something in the queue. Is it like a pop? We can pop off the queue, so that should return our thing, right? It seems so confused about this indenting. Not sure why. Is that gonna, no, it's still, Sometimes maybe if I like close and open it again, is that the right one? No, I think it's this program file. Maybe now it will, yeah, now I think it's doing 2 spaces. CLion does something where it kind of like, it looks at the file and says, oh, what kind of indenting do you use? And I will keep using that one. And it seems like you have to close and open the file if you change that so that it can reset. Okay. So, well, this is a qualified name here. Oh, fuck off. That's the qualified name. We have the program. So we get the procedure. I guess we can just put that there, really. So we pop off the queue, which means that it's going to be like last in, last out, the queue, but the order doesn't really matter. And then we're going to say, like, if, this is important, the first thing is if procedure.type checked, continue, nothing to do. I guess it kind of makes sense to say type checked after you're finished. Yeah, that's safe. I was a bit worried that, like, in here recursively we end up doing this again, but that's not how it works. In here we would just add more things to the queue, but then we would come back out, say type checked equals true, and then if we re-added this procedure to the queue, this would catch it. Okay, so a program is the program. Oh, we need module name, procedure name. So I think actually this, this is pissing me off. This is a reference that we want in the queue, I think, which was like my way of having both things. And then we would need to do the qualified name business. I guess it's program. Okay, qualified name, which takes module name, procedure name. Like that, and then we use the qualified name to get the actual procedure. Like so. And that means that we can also build our context correctly, since we have the separate names, and then we can type check. So to begin with, we're going to type check this module, which may have top level imports, which means that it would type check the top level of other modules, but any procedures in any of the modules would just get added to the queue, which would then get processed here. And you can see how with this structure later on, this queue could get processed in parallel, right? It doesn't have to be single threaded, but that has some implications, so we're not going to do that right now. I'm really curious if this is going to work. I hope so. I think that's basically it, although when we add to the queue, where was that? Statements. I think that should be broken now. Yeah, because it's not the qualified name. It's the module name. Yeah, it's these two elements separately. Okay, let's try that. Okay, whole load of errors. I guess I have to do, I don't really like that this is, I'm not sure what the reasoning is for this being, needing to be explicit. Okay. So we got somewhere, and I guess we were type checking bang, and we got to here, and we were like, I don't know what my I-64 is. The type was not found. Okay. With type not found, the thing with type not found is that this is really recursive. And that wasn't a problem before, but now that this is really, the idea here is that we're really just processing this scope, not any nested scopes or anything like that. So if we come in here and we're resolving types and we're recursing, I think if we come down here and we realize that actually this child node is itself a statement, then we need to say like, let's not recurse anymore. That'll get dealt with when we process those statements. That's not the job of this right now. I think that might be why this shows up. So let's try that. So if I go into resolve types to the recursion, I think it's like this. I can't remember. I can never remember the order of the return things. Is AST.statements? So I think this is how we check. So we check the type of the child node to see if it is a statement, like there's the list of statement nodes types that we're searching through. And if we find that, so it's index found. So actually I wanted this the other way around because what I care about is found. So this should be a Boolean. So if not statement, then we do this. Hopefully that should fix the i64-bit. Oh, types my64 and i64 are not compatible. My i64 is i64, so why would that not be compatible? Interesting. I wonder what it thinks they are. And then strings is not defined. I guess happens there on line 36. Even though it's defined here. So we are going into procedure, which means that we get a whole new context. But it should be able to look up. Oh, no, this is a nested procedure. Ah, interesting. Okay, so that's a bit more work we need to do. But I think this should work. The reason it did not work is because if we go back to, I think it was in context we did it. Yeah, we go back to this here. And it looks at the current scope, the current thing we're in, and then it goes up to the module. But in this example case, this is the current scope we're in, and then it goes up to the module, which means that it skips this outer procedure. It doesn't look here. So if I do that, yeah, see, now it's happy with that. But it's not happy with my i64 business. Oh, it actually crashes. Is it the compiler that crashes? It is. Interesting. It's in an infinite loop. It's an assignment. Yeah, so it's an invalid. An assignment is not a primary. Generate primary, generate expression. So if we go out to where it looks kind of sane, and we have a look at the left-hand side, this is my proc. So maybe there's a bit more work required with this procedure business. So it's generating the right-hand side expression. Should be this guy, which is an import statement followed by a print line statement, which should be totally fine. And then it goes into that expression, into here, and says we're not talking about a binary operator. Because we are... wait a minute. Wait a minute. If it's the procedure, it should not be going into generate assignment. It should be going to generate procedure. Okay, let's have a look at this program generation business, I think, yeah, so for the main procedure stuff, we have this generate statements, which is, so this generate statements, and maybe we should rename this, because this is actually like main statements. So this is like the, the body of the module. And it looks for all the modules that have been imported and generates the main statements for them, for all of them. And then when it's doing the actual statement generation, it skips over these. Like these are the special cases that it should not do. But if we go down to generate procedures and generate procedure, we can see, yeah, just it generates the statement, which will generate everything. So maybe we also need to have, within generate scope, we also need to have generate statements, which is like skipping all that stuff. So this is actually generation of x86. Statements, generate statements. So again, we'll say like statements is AST node. Oh, that's right, he puts them at this front, doesn't he? A few differences between his syntax and mine. And that is just going to be basically this for loop. And then I'm going to cut all this stuff out. So it goes through all the statements, skips those, and does generate statement on the ones that are not special. Yeah, that seems right. I think there's probably a lot of things that it does not need. AST and this, it does, the generation is this. Strings, slice, format, none of those are used. Okay, so that's statements. So then if we go back to the program, here, we would say generate statements, pass in the context and this as a slice instead of doing this. And also in the scope, we want to do the same thing. Let's close a lot of these files. We've got heaps of files open. Okay, so in the scope, we also want to say, hey, generate statements so that we skip over any of that madness, or the special cases that we don't want to process, like so. Oh, got an error. Okay, at least we're not like having infinite recursion now. Okay, an assignment, the left-hand side node is kernel index, my64, 2 byte size, and I think the type node is still, yeah, it's my64 because it was not found. And I'm a little bit wondering, why was it not found? Let's get rid of these. So we declared my64 here as a type alias, and it's not being found here. The this should be taken care of in the first pass. This is statements, right? Well, this is type checking is where this should be happening. So there's resolve types. So there's the type alias. When we come across the type alias, it should get put into the context identifiers. Yeah. And then we resolve the types. We look through here. We should get that. So let's check, when we get a type alias. I think there's not too many of those. And what are we doing? We're saying struct. I guess what we want is name, don't we? Time val. Okay. So we make it time val, semaphore, vec4, task pool. A little bit inconsistent. I should probably put _t on all of them. That's what I like to do. Okay, my64. So we're putting it in the context identifiers. Now we continue through the statements. So our current statement is an assignment. We want to get to the for loop, I think. Yes, so we've got past this. I guess it's this assignment, then a right-hand side expression, and then it should be our for loop. Yeah, call is the right-hand side expression, and now our for loop. So when we resolve our types, because when we resolve our types, because I prevented it before. Before I said, okay, so we're here, right? This is our statement. This for loop is our statement. And the first thing we want to do is resolve types, right? So we go through the AST of this statement, and anywhere where we find a type, like here, that correlates with another type, we effectively replace this with this. But as soon as we find a statement, and this is a statement, we stop. So how do we prevent that? Maybe actually what we're trying to say is when we find a scope, a nested scope, that's when we stop. I think that works. So like all these statements in here will get done, but here we find a scope. So then we're like, okay, now we stop, and we don't try to process these. Let's try that. As I say that, I'm realizing that, this is a bit of an issue. Like if there's a for loop that does not have a scope explicitly, like doesn't have these braces, then that could be a problem. But that's also a problem that I want to solve, that if you don't explicitly put these braces here, then a scope should get inserted there anyway. Yeah, okay, so let's try that. And what the hell did we say we were going to try? That's right, we're going to say if this does not equal scope. I think that was it. Yeah, so we don't recurse into nested scopes. Let's try that. We don't want to break there anymore. Okay. So now we're getting a linking error, which I expected because I just said let's link bang, which doesn't exist. But that means that it assembled correctly. So everything is happy. Just when it tried to link, it was like, hey, I don't know what that is. So let's take that away. I mean, if I tried to link GL, there would be a duplicate. Is that an error? Oh, I think it might be in caps. Oh, that's fine. Okay, and it's calling nested proc a lot, which makes sense because it's in the bang, which we call every frame. Cool. So that's working, right? It was, yeah, triangles are moving. That's a good sign. It's calling my proc. So like I said before, we do have this issue. See, it's saying core boomstick module and then just my proc. It should be bang.myproc because it's nested within bang, and we don't want to prevent my proc from being used elsewhere in the file in different scopes. So we need to resolve that. But this is pretty good progress. I'm pretty happy with this. So now we can make type aliases wherever we want. We can do imports wherever we want. This is not really supported. We can also do links wherever we want. Yeah, so we just need to improve the support for this. But apart from that, I feel like that's a nice change. And then module is just basically just fetching the main procedure of the module, type checking it, and then putting the identifiers in the module. That's basically it. Okay, cool. So let's, I did clean that up, it looks like. I could leave, well, let's just revert that. We could nest memory in here if we wanted to, but I'm gonna leave it for now. Awesome. So that takes care of this. It was just 2 bullet points today, but I feel like they were, and they weren't features unfortunately, but I feel like they are going to help enable a lot of this stuff. You know, some of that work that we did today is actually going to help with generics, definitely help with nested procs. You know, I think to finish off nested procs, the only thing we need is that naming. Improve that naming. So I'll leave this here as basically to say, let's improve the naming. Anonymous procs is going to be something a bit more difficult. Yeah, so it helps. And it helps with compiler performance. It helps with quite a few things. Cool. All right. I'm happy with that for now. Enough for today. Thanks for stopping by. Have a good one. Ciao for now.